Alright guys, so in this video I'm going to be teaching you how to build a complete RESTful API in Golang. We're going to be building a project manager like Jira, and we are going to be adding features like authentication, creating end connection to a database, so it's going to be a MySQL one, could be anything. We're going to add dependency injection, we're going to test all of our services and even dockerize the whole thing so we can ship it to the cloud and all of that good stuff. I was debating between making this video or not because I see there is a couple of videos out there about this already, but I've been creating all of these projects and APIs in the channel, but I've never really explained you how to create an API from scratch. So this video is going to be a reference point for that. Regarding what we are building, it's a simple project manager like Jira, where we have a couple of endpoints for authentication, managing the projects and the tasks. And so this is the rudimentary structure. So we have the dependencies, which is going to be a store or a repository that is going to be injected into all of the services. And then the services are going to be registered into a MUX router that we're going to see how we are doing in a bit. And then this is the overall structure as I've shown you. So these endpoints are guarded by authentication. And then here on the API server, we are communicating with the relational database, which is going to be MySQL, but you can add anything you'd like. All right, guys, so let's get coding. And the first thing that I already did is that I initialized the projects with the Go in it, and I have created a make file with just a simple run, which is with a build and a test as well. So the run is going to build the project and then is going to execute the executable. And here I have an empty main file that we can start coding. And before we even start coding, I want to mention that in this channel, I teach you Golang. So I try to avoid using frameworks as much as possible so you can learn the fundamentals in order to become a high-value engineer. So that means that we're going to use as much as possible the standard library. Of course, we're going to add packages like MySQL driver and JWT token as well, but those are important to make sure that we have a secure application and not implement those things ourselves. Otherwise, the video would also be hours long, right? So the first thing that we're going to be doing is that we need an API file where we're going to start the server and anything related to that. So here, let's keep everything again on the main package. So here we have an API server. The API server is going to hold the address for the server. So for example, port 3000, and then a dependency, which is going to be the only one that we have, which is going to be a store. The store, that, as I shown you, it's the repository that's going to have all the connection to the database. So this is the only layer where we have a connection to the database, and we can inject this so we can easily test it, right? So let's have here a constructor, and I've noticed I have Copilot enabled. Let me just disable that. All right, so here I just created a constructor for the server, so we can go here to the main and say that we want the API, and let's just say new API server, and we pass in the other, which can be, for example, 3000, and then a store, which you don't have it, so let's just keep it nil for now. So just below this constructor, we need to add the only method that this server is going to have, which is the serve. So let me just add a method, which is going to be called serve or run or whatever you want to call it. But the idea of this method is to initialize the router, then register all of these services and their dependencies, and then at the end we just listen for the server. So we just start the server and log for any errors. So it's going to look like something like this. So router.mux.newRouter. So for this, I'm going to be using Gorilla Mux, which is the only package that I like to include for HTTP handling and all of that stuff. If you are familiar with that, you know that it's way easier to do this than manipulating the path and the query parameters from the standard library on HTTP nets, right? I like to keep it on all my projects. It's a standard for me. Then I'm going to create a subrouter here. And the idea for this subrouter is so that we can prefix the API with /API and /v1, which is also a good practice to have. And then at the end, we just log the error that might come from the http.listen and serve, which I'm going to be listening at the port from the other. So it's going to be from a parameter, and then the handler is going to be the subrouter. And this is it, the very simplest way that you can do this. And then here we are registering our services later in the video, okay? I'm just gonna also add here a print line, just so that we say starting the API server at, and then just so I have some logs when it started. So the next thing, let's go ahead and create the store file, just so we can get ahead with this error. So the store, because it's an interface, we can easily inject it into the services, and then because of that, we can easily test them because we can mock this interface as well, right? You're gonna see that in a bit. So a method that we can start thinking about is about the users. For example, let's have the create user, just so we don't have an empty interface for now. And let's just return an error. We're gonna come back to this and change it later, but for now, this is it. Then just below, let's create a structure called storage or repository, which is going to be a struct. And this is going to be the struct that is going to be having the methods to communicate with the database. For example, it's going to receive the dependency of the communication tool. For example, it's SQL, and then just below, let's also create a constructor, new store, and then we have db. We can also just go ahead and create the method for the store so that it implements the interface. So storage, and let's have a create user. Doesn't take anything and it returns an error. Let's just return nil and keep this empty for now. So here on the main file, what we need to do is create the store, new store, and then here we pass a database, which you don't have it yet. And for that, let's create a new file called db.go. In here, we create a struct called MySQL storage. This is going to be the implementation for MySQL, and it's going to receive a database as well. Then let's just create again the constructor. It's going to receive a config, and this config is going to be coming from mysql.config, and it returns a MySQL config storage, MySQL storage. So here, this is where we initialize the database and make the connection. So let's go ahead and do an sql.open. And here we pass in the driver name, which is MySQL, and then the connection string, which is going to be connection, config.format, DSN, and then when we just, it returns this. I need to import the package, otherwise I am getting these errors. And then let me just simply handle the error, which at this point we can just fatal log it, because if the database connection fails, the application is going to fail, so we can just stop it. Then the next thing we do is we go to database, so we can ping the database. Let me just remove this one, and again handle the error. So if you look here at the documentation, you can see that open might just validate the arguments without creating a connection. And to do that, you need to call ping here. So that is very important. Then let me just do a log.prints ln, just so that we know that the connection is successful, connected to MySQL. And at the end, let me just return the storage with the dependency in there, right? So back here at the main file, let's create the MySQL connection. So for that, we need to have the configuration, mysql.config. Let's go back to this in a bit, but let me just get here the SQL storage and get the MySQL storage and pass in the config. Then here with the SQL storage, let's go here and actually get the database from it. So SQL storage.init. This is a method that we still need to create. And if there is an error here, I'm just gonna fatal again with the error. And then here we have the database dependency. And here we can just say that we pass the star. And there we go. And here we can actually call the serve because we have already created this serve, api.serve. And so the last thing that we need to do is actually create the init method on the storage. So let's go back to the database, create the init. So this method is going to return the actual pointer to the database and an error. And the reason for creating this method is that we need to initialize the tables for the database, and then we just return the database. So we already have it created, but the tables are not created. So here we're going to initialize the tables in a bit. For now, we don't have anything to initialize. So let's go back here and finish the configuration. So for the configuration, we need the user, it's going to be the root, for example, the passwords, my passwords, address. I'm going to keep an empty string for now. The database name, it's going to be project manager or something like that. It's going to be TCP. And I'm going to add some properties that I usually add to avoid errors in the future, and the parse time as well. Okay, so the first thing is that we should not keep these variables here as strings. So what we can do is get them from the environment variables. So let me create here a config.go. This file is going to be responsible for having a hold of the environment variables in the runtime of the server from the injected variables that we're going to have. So it's usually best practice to have the environment variables injected into the runtime instead of just having them hard-coded into the project, right? So this is what's going to be the responsible of this file. And the idea is that we have this variable called envs. It's going to be global, and then you're just going to initialize them from a function. Just going to call init config here, and it's going to return a config object. So the first thing is that we need a port, and to do that, let's create a function that actually gets this from the environment variable. So get env, it's going to be the key name and a fallback. Both of these are strings, and it returns a string as well. So this is the trick. So let's do an os.look up env for this key, and if it's okay, if it exists, then we just return the value. Otherwise, we just return the fallback. And we need to import os, but this has an error here, so let me just complete this. And the key is going to be port, uppercase, and then the fallback could be like 8080. And now the project doesn't have error, so we can have the import here. The next one is the DB user. So these are the configurations that I've just filled in. So the first one is that we have again the port, the DB user, the password, the address for the database connection, and then the name. And lastly, we have the JWT secret that we are going to need for the authentication. So with this, we can come up here and change this all together with envs.user. In this case, it's the DB user, like so. And I think the main file is complete. So we have the MySQL storage configuration, we initialize it, and we have a store, and we are injecting it into the server, where here we are listening. So the last thing that we need is, of course, start creating our services. And the first one that we can start off is, for example, the users or the tasks. Let me start with the tasks so we can have some functionality, because the users is going to be the authentication. So here, each service is going to have their own service structure. So they are going to be lookalike, because all of them, as it's on the diagram, are going to receive the store, has a dependency. So this is how they are going to be structured. And then we can have constructors for each of them. So task service, which is going to receive the store, and it's going to return a task service pointer. Then the method, the only public method that we have for the services is a register routes, which is responsible for registering all of the routes. For example, here we have the handle creates task, and then the get single task, for example, as we saw here on the diagram again. These are the endpoints that we're going to be creating for the tasks. And then each of these is going to be also a method from the service. So handle create task. It's going to be receiving an http.response-writer, and as well as a request, a pointer to the request, as you might be familiar. And then the other one is the same, so let me just copy it. There we go. So here we can go back to the main inside the serve and actually register our first service. So it's going to be the tasks service and new task service where we pass in the store. And here we just initialize it, task service dot register route, and we pass in the router. And there we go. Now we have our API with these endpoints. So before running our application, there is one thing that we need to make sure is that because we're running this locally, and my setup is that I have a Docker image running MySQL locally, and these are my credentials. And then what we need to do is make sure that we have a database actually called project manager, right? So for that, let's do that manually. So I'm here at my SQL client, and I'm just going to do a create database project manager. There we go. Now if you run the project, we should be connected to the MySQL, and then we are listening at port 3000, which is what we are. Awesome. Alright guys, so here back at the implementation for creating a task. The first thing that we need to do is actually get the payload from the body. So what we can do here is we need to access the body from the request. So we're going to do io.reads all, and here we pass the request.body like so. Let's just handle the error like so. So here I'm just going to return for now, and then we're going to create a helper function that we can use on all of the responses that we write JSON for it. So let's keep this for now, and then let's close the body, very important. Dot close like this. So the next thing we need to do is actually convert this slice of bytes into a structure that you can read, which in this case is going to be like a structure of a task. So let's go ahead and create a new file called types.go. Inside here, let's create a task struct, and the task struct is going to basically hold the entity or the information that the task is going to have. But before that, let's go ahead and initialize the tables in the database, because we haven't done already, and that way you can already translate that into a structure. So here the first thing that we need to do is actually create 3 tables. So for the projects, the tasks, and the users. So here I have created 3 functions, and we are handling the errors, one for the projects, and so on, so on. So for the create projects table, here we are creating a table. So we're just executing raw SQL here, and we create the project which has an ID, a name, and a created timestamp. As well as for the tasks, we are creating with an ID, it has a name, so a task has a name, a status, and the status can be to do, in progress, testing, done, and the default one is to do. So we don't need to pass it when we create a task. And then it is associated with the project ID and associated again to a user ID as well. Everything with foreign keys here. And finally, we have the create users table. Very simple. A user has an email, first name, last name, password, and a timestamp as well. So we can save this. Next time that we run the project, all of these tables are going to be created, right? So back here in the types, if we check what we already created here in the database, we know that the task, it has the structure, and I have just translated that into Golang here, right? So here what we can do is actually get a hold of a pointer to task. And now we're gonna unmarshal this. So we're gonna do JSON.unmarshal, and we're gonna send in the body, and we're gonna unmarshal it into the task and handle this error appropriately, which we're just gonna return for now. We're gonna go back to this in a bit. And then we have a task. If everything is alright, I have a task written here. But there is a problem, which is there is no validations inside the task. So the name could be empty, or either the projects or the user could be empty. So we need to have a way to validate. Very easy. Let's create here a function that is going to validate the task payload. Okay, and let's send here a task. Then if the error is different than nil, we are going to return, yeah, so let's go here below and create this function that's going to receive a task. And it's going to return an error. So for the validation, this is what I have done. So if the task name is empty, I return a predefined error that I have created here. So there is 3 ones. This is just so we can easily access them on the tests and match them in case they change in the future. They are a constant here. So the project ID the same and the assigned user as well. So here, let me just fix this. So if everything worked out, we can go ahead and go to the store and create the task in the database. So for that, let's do a s.store.create task. It doesn't exist yet and we're passing in task. So let's go back to the store and add the create task to the interface, right? So it receives a task, returns a task, and the implementation is going to be pretty simple as well. So here I have the function signature, and the first thing we do is that we execute an insert into the database with the values, and then we basically handle the error, and we get the last inserted ID and append it to our structure and return it to the user. So we have a new ID updated. So back here, let's just handle the error, return it, and with that we are done. So here at the end we will just return to the user the task, and this is where it makes sense to create some reusable function to handle JSON to the user, right? So here let's create a notils.go, and the first thing that we do is add the package main, of course, and then we are gonna create a function called write.json, like this. So it receives an HTTP response writer, so we can actually respond the requests to the writer. A status could be 404, 200, and a v, which is the payload of anything, right? It just imports the HTTP. The first thing that we do is that we set the header to be .set, and it's going to be a content type. So we need to set it as JSON, application/JSON. Then we need to set the status header, so we do write header with the status, and finally we encode the payload or the response has the v, which is anything, so we can just send anything we would like. There's another thing that I want to add here. Actually, it's not going to be here, it's going to be on the types, and it's going to be a type error response. And this is going to be consistent when sending errors to the user, because we might just throw a different message, but we want to send a JSON with the same structure, so any front end, any client can consume and expect the same output from an API. And that is very important to be consistent when writing any sort of API. So back here at tasks, we can just call the write.json, sends the w, and do an http.status created, and then we can send just a task, right? So this is gonna work out, and then on the errors, what we can do is, so for this one, I just write JSON, I send that it is an internal server error, because if the creation of the tasks fails, it's probably on our end, because the validation should take care of that. And here, we just send the error response like we had created, and we're gonna do the same one for this one. So instead of being an internal, it's going to be a bad request. It's probably because the user entered a bad payload, and here we say error. It could be, actually this one is dynamic because the error comes from the validation, so it's error.error, like this. And then where do we have more? We have here on the JSON, which you can say invalid request payloads, and it could be the same one for this one right here. Okay, so this is how you're gonna handle this. So here I have an HTTP client open. You can use Postman or something like that, but I use this client on VS Code, which is called Thunder Client. And basically here we have the URL, and let's hit send, and I'm getting a 404. So something is wrong with the task URL, which I don't think it is. Let me see on the API, because I think, yeah, I see the error. So instead of passing the router, we need to pass in the subrouter, because it is /API/v1. If we just pass the router, it's without that, so we want to use the prefix. So make sure that we correct that as well. And let's try again. So we got an invalid payload, and it makes sense, because if you take a look at the task validation, you see that we are failing here because we are missing the name, the project ID. In this case, we actually have the name, but we are missing the project ID and the assigned to ID as well. And the reason that I'm not passing it yet, it's because we need to create projects first in order to pass them, and users as well, right? Otherwise, we are getting an SQL error, because those are foreign keys and they are validated against the tables. So we can go ahead and move on. We can make sure that this is actually somewhat working, but I'm not 100% confident yet. So what we can go ahead and do is create a test for this, right? So let's go and create a tasks test. And this is going to be where we actually test these endpoints and see if it actually works before we move it to production. So let's start with it. So here I have a test create task, which is gonna handle the testing for this endpoint that we just created. And the first thing that we can test against is should return an error if name is empty, for example. And the payload is going to be something like the task with the name being empty, for example. And how do we do this test? Is that first we need to encode this as JSON. So let me go ahead and transform this into bytes with json.marshall. Pass in the payloads. And now we have that. We can actually just make the application crash here the test. So let's do a t.fatal with the error in case that fails, which is unlikely. And then let's actually make a new request. So this is how you test HTTP handlers. http.post /tasks. So here we don't need the prefix for the /v1, because we are creating a very small router for this test. We are not using the API.go, so this is not being run. When we run this test, we just make a request for this, and below we are going to be writing the let me just show you. I think it's easier. So here we have a new HTTP tests dot new recorder, and then here we have a router, right? mux.new router. So for each test, we are creating a very small router, and then we just say router.handlefunc. And we say, for example, this is the only route it has, and it's the service dot blah blah blah. So in this case, it's going to be the handle creates task. And we need to first create the service as well, which we're going to go back to it in a bit. But here, let me just encode the payload as bytes. So here you do bytes.new buffer, and we pass in the bytes that I have here. So the reason for this is that if you look at the new request, it actually requires a reader and not just bytes. So we need to make this reader of bytes. So how do we actually get the service from this one? Let me just go ahead here and do a new task service. And this is the problem now. We need a store. And this store, if you remember, it's the interface of the dependencies. And we cannot pass the storage that we just created on API.go. On the main.go, actually, sorry. We cannot pass the storage because this is communicating with MySQL, and we are building unit tests and not integration test. So we don't want to be mutating data on the database. So we need to create some sort of mock for that interface. So here I have a memory storage, which I'm going to go with. And let me just do a mock store, which is going to be a struct that we're going to be creating. We can create here, for example, store.tests.go. And this is where we're going to hold all of our mocks of the storage. So let me just call this mocks here, and this is the structure. And every time that we change that interface, we need to change this as well to match the interface implementation. So if you look at the store here, it has these two functions. So we need to implement these two functions in order for the mock store to work. So let's have the create, which just returns an error, and this is whatever you want. You can just return nil. And then again, we need the mock store for the create task. And we can just return nil, or whatever you want. Here I'm actually just returning an empty task, like so. And so this is the beauty of dependency injection in Go, which is you can just implement any interface and you can just inject it however you like. So you could create here an implementation for this test or something like that, and it would work. So if the implementation is implemented correctly, we are not getting an error if it is. So if I go here into the store.test again, and I remove this one, you can see that here we have an error saying that it does not implement store, it's missing the create task method. So it's very nice as well that we can see these things. And here below, doesn't have an error, and we actually have the handle create task ready for that. Then what's missing is that let's go to the router and serve HTTP for this and these requests. So this is what the request recorded that we just created, and that this is the request that we just made up. So we just cooked these fake requests, and here we have a recorder that we send for this router for this test. So this is how we create isolated tests in Golang using Gorilla Max, for example. But it works with any package as long as you understand what's happening behind the scenes. So the first thing that I want to check is if the code is not an http.bad request, because these should fail. If it's not one, then let me just do an error invalid status code, right? And let's go ahead and actually try this test. We have here an error. Why? It's because of the error. So let me just handle this error really quick. Error. And this is it. So let me go ahead and do a make test, and all the tests pass. If I change this to be a status accepted, for example, and run the test again, this is going to fail. It fails. So we are more confident that the validation that we just tested is working. As well, I have just created here very quickly the happy path. So it should create the task. Here I'm passing a valid payload. I do the same thing. I marshal it, I send it, and then at the end I just check that if the status is different from created, and if we test this, we see that everything passes, right? So if you want to get the hold of all of the tests, I'm going to be leaving the whole project on the description below, so you can follow from there. Alright, so here on a GET request, the first thing that we need to do is, if we look at the signature of the endpoint, we are receiving an ID, so we need to get that. And this is why I really like Gorilla Max, because we can just do this, and it's way easier to parse it than if we would do with the standard library. We can even create a function to abstract all of this if you did that many times, but I want to show you how you can do it first. So this is how you get the ID. If the ID is empty, then we also need to add a validation for that. So let's just write JSON and say that the ID is required, and then let's just return out of here. Then we got an ID. What we need to do is get the task from the store. So let's go server.store.get task. We don't have this method, and we are passing an ID, and that should be fine. Let me just handle here the error really quick. So I'm just going to say here that the task is not found. And Yeah, I think that is fine. Then let's go here to the store. So here on the store interface, what we need to do is add the get task. So here we're receiving a task. Actually, it's going to be an ID, right? And then we return a task and an error if there is one. So let's go here down below and do like so. So this is what we're going to do. So we're going to have a variable to hold the task, right? And then the way that we do this is let's do a select ID, name, status, and everything that we want that we have in our structure from the tasks, and we filter by the ID. And then we scan the results from this into the task like this. So here we are passing the pointer for the properties that we have selected, and then we just return this to the user, and we are done with this. Let me just as well go to the store.test and add a new mock for that here so that the tests don't fail. And here let's just return a task and null, like so. Okay, let's go back. Here we don't have an error, and we can just return to the users that we have found the task. So let's do an http://OK with the task on hand, and this is the get. So it's very simple. We could expand a little bit more, but this does the job for it. And then here on the test, let's also add a case for the get. So let's do func test get task, and I'll fill up the rest so we can move up a little bit faster. And here is a simple test for the get task. I just noticed I have here a typo. So it's very simple. The difference is that we are doing a get method. This is the different signature as well. And then again, we search if the code is okay instead of created. Now, there is a thing that I've noted while creating these tests, and I think this is one of the benefits for creating tests and Golang and why it's so easy to create tests, is that there is no way actually to have an invalid ID here. Of course, I could put a string, but let's not go into that deep. So I think this validation here can go away. And just like this, because if we deleted this, if we make it like this, what would happen is that it would throw 404, or it would go to another request because it would not match this string. So it's completely fine to just remove that validation there, okay? So if we record back to the initial diagram, we've just created these two endpoints for this service, and they are guarded by authentication. Right now, we have no way of doing that here, right? So these are unauthenticated. Anyone can get and create tasks. So let's fix that and add authentication to our API. To do that, let's create a new file called auth.go. And you can see the pattern that I'm going for. So anytime we need a service, a bit of functionality, we just create a file here on the main package and we add it. Very simple, so without much trouble. So what I'm thinking of doing is creating a higher order function, some sort of way that I could wrap each endpoint that I want to add authentication and say that, for example, this could be with JWT authentication or just with JWT auth. And then I would wrap this handler with pre-check. So this would run first, and then it'd call this function if it would be authenticated. If not, it would just throw some sort of error to the user, some permission denied. So I think that is what we're going to go with. So here, let me just create a function with this name. It's going to receive a handler func. So that is a handler function, and that signature is from the http://handlerfunc, pretty standards. So let's just return the handler func, and then inside here we're going to have the algorithm, the logic that we need to validate the token. So the first thing that we need to do is actually get the token from the request. So inside the cookies or something like that. Actually, it's going to be from the header. So we're going to have an authorization header. We're going to get the token from there. Then we validate the token. Of course, if the auth header is not there, we just throw unauthorized. Then we validate the token. Then we get the user ID from the token. So inside of each token is going to be encoded the user ID so that we know from which authenticated user is, and then we just call the handler func and continue to the endpoints. Right, this is the overall structure that we're going to be building. So to get the token from the request, we need a function. So let's create it down here. I called it get token from request. So we just pass in the request and we can get the token. We can use this here or even on the handler functions as well. So the first thing is that we get the token. We can get it from the authorization header, or we could also get it from the URL as a token query string. So it would be, for example, /API / blah, blah, blah. And then we could get it like this, the token. Then we check if the token is not empty. And then we also check if the query token is not empty. Because if this one is not empty, it exists and it just gets the header. Otherwise, we get the one from the query, else it's empty and we just return it like that. So let's consume this here. Let's call this token string. Pass in the request, and then we need to validate the token. So let's have a token and error, and let's maybe create a function called validate JWT, where we pass in the token string. Let's create this function below. It receives the token, and it returns a JWT dot token. This is from the JWT package for Golang. So let's just import it here. It's this one that I'm using. There is multiple flavors of this, but this is the most used one. Then we need to get the secret. So this is the secret that we created on our config, if you remember, this one. This is how we are going to check and decode the token. So we need this key to open the token. Otherwise, anyone could open it. So let's go to env.jwt secret. We already had this set up from before. That is awesome. So let's just return a jwt.vars. We pass in the token string. And here we need a function that is going to run whenever we parse this. Then inside here, what we need to do is check if the signing method is an HMAC, because it could be an RSA or something like that. So here we check if the method is an HMAC, and then we just return an error if it starts. And then we just return a slice of bytes with the secret. So the last thing that you need to do here is then handle the error. So let me just check if the error, then we return from this file, because we don't want to continue calling the endpoint if he's not authenticated. And then we need to say to the user that he's actually not authenticated. So let's have a log here so that we know what's happening. And then we just write JSON with an authorized error and the response that permission denied. So here could be a print ln, and this is what we do. Then now that we have a token, so we have a token of type JWT.token, we need to validate it as well. So now that we have a token, we can start to see and get the claims for the token. And inside the claims is going to be the user ID. But first we need to add here a token. So let's do a token dot valid. I think this is it. So if the token is not valid, copy these lines here and paste it here. So you can see that this is going to be repeated. So when you see that repetition, let's add a function to do that. So permission denied. And what we can move here is just this one, and we could even, I'm just going to move the log because the right JSON, because the log could be different. So this is going to be an HTTP writer. There we go. And then we just replace this with permission denied, and that's, there we go, much cleaner. So to get the claims, what we can do is go to token.claims and map this to a map claims type. And then we just get the user ID from those claims as a string. Then we need to go to the store and get the user, but at this function we don't have access to the store, as you can see up here. So let's go add the dependency to a store, And now we can get the user by ID. So this method does not yet exist, so it's something that we are going to create. But let me just handle the error here. Just like the same above, let me just copy it actually. If error is different than null, we just return this. And here I'm gonna say failed to get user. And then at the end, if everything works out, we call the handler func by passing in the writer and request. And this is gonna call the endpoint at the end. So let me go to store real quick and add the get user by ID function. So this one is going to receive a string, and then we just return a pointer to user, which you do not have yet. So let's go to types. Let's create a user struct. And the user is going to have an ID, the first name, the last name, and then also the password. And I think it also had, let me check on the database. It also had the created ads. So let me just copy this line here as well. So this is going to be the user struct. And now let's create the functionality for the storage. Get user by ID. Here we also need to add the email, almost forgot, and very similar to how we get the task, we get the user, so just select the user and filter it by the ID, and this is done. So let's go back here to authentication, and it should be completely done. So we have this higher order function that validates if a request has a token associated with it, right? So let's go back here to the handle func and see how this works. So we need to add the store dependency. And there we go. So let me also add authentication here to this endpoint because it makes sense. S.store. And there we go. So both endpoints are authenticated as we designed it. So let's test it out. Now, if we try to create a task, let's hit send. And we get an error because the server is not running, of course. So let's hit send again. And we get unauthorized because we don't have a token. So we have a permission denied, and here are the logs that we wrote. So that is working. We have authenticated our services. So let's make a way to create a user so we can also get a token, but as well as a user in our database. So again, very quickly, I have created a new file, which is the user service. And just like we did before, this is the structure. So we have the user service struct and as well as a constructor. I registered the route for the register, which is not authenticated, which makes sense, right? We are authenticating right here. And here we are with the register endpoint. So the first thing that we need to do is get the payload. So it's going to be the email and the password. So let's start reading the body. And then we close the body. And then here we marshal everything into the user struct, right? Then, now that we have the user payload, what we need to do is create that user. But just before that, I think it's wise that we validate this payload again. So we should see if the user is actually filled correctly. So here we have the validate user payload, just like we did with the tasks. And here we check if the email is empty, if the first name, last name, and the password are all filled in. So because they are required. If you want to make the first name and last name optional, you can just delete them from here. I want to make them mandatory, so I'm gonna leave them. And then here just validate and throw an error if not. So the next step would be to store the user directory, right? So here we have a new method that we're gonna create, the create user, and then we just validate the error. But there is a problem here, which is if you take a look on the payload, we are sending the password as plain text and we are storing it as plain text, which is not a good approach to do it. So we should encode the user's password before storing it in the database here. So that is what we're going to do. We're going to hash the password. So we're going to have a hashed password. And let's have a method for that called hash passwords, where we send the payloads dot passwords. Then let me just handle the error right now, and then the last thing we do is go to the payloads dot passwords, which is going to be equal to the hash passwords like this. So that's password is never going to be sent to the database, only the hashed one. So let's create this function inside of our auth service. Just below here, we're going to pass in a password, has a string, and we're going to return another one has a string like so. So the way that we're going to do this is that we're going to be using a package, a very famous one called bcrypt, and that way we can make sure that our API is secure, because this is a very trusted package, and anything related to cybersecurity and all of that and encryption, we should not be handling that ourselves and leave that to someone who knows it better. So this is what I'm going to do. So bcrypt.generate from passwords, where we send our password and a default cost as well. I handle the error, and I just return a string of the hashed value, right? So back here, I just need to import our package, and then on the users, we should have the hashed passwords on the payloads. So back here in the store, this is the very first method that we actually wrote in our store, and we need to update it with the payload. So it's going to receive a user, and it's going to also return a user, because at the time we didn't have any of this. So let's go here and delete this implementation and implement it ourselves. Again, this is the implementation. It's very similar to what we did before for the tasks, so I'm just going to skip it. So I'm inserting into the users, and I get the last inserted row like this. And now we have a user stored in our database. And the last thing that we need to do is actually create a token and a session for that user. So I'm going to go here and do a token error, and let's have a function called create and set auth cookie. So we're going to set directly in the cookies for this user ID. This is what we need. And let's set here the response, because we're going to need this. I'm going to go down here below and create this function. So for this method, what we are going to do is create a JWT. So here I have the secret from the vars, and we're passing it to this implementation that we're going to see in a bit. I handle the error, and then I set the cookie for authorization. You could set a header, you could set whatever, and then we just return the token. So let's go back to authentication and create that function. So this is the function for the create JWT. It receives the secrets, as we saw, and then the next thing that we do is let's start by creating a token with claims. So let's do the JWT.new with claims, and here is a signing method that we are checking before that we saw this. And here we have a map of claims. We're going to send two claims. The first one is the user ID, and then the second one is an expires. So it's the expiration date for the token. You can add here the time that you want. And here we just get the token has a string, so that we can just return it here as token string, and an error, which is not going to happen, so we can just return nil. I've also noticed that here on the hashed password is not returning the error, so let's go here to the users, and let me just fix here. I'm going to ignore the, no, I'm going to read the error, and then here have user ID, which should be ID, and we are returning a string and an error, just like this. So this function is complete. Here we got a token and an error, and we can just return to the user finally that the user has been created, and we can pass in the token for the payload, for example. Just need to handle this error really quick. Error creating session, for example. And this is the register, and let's go ahead and test it. So I'm back here running the server, and I'm on my Thunder client. So this is the user/register. So there's one thing missing before doing the request, that is that we need to go to the API and register this new service. So let's go here and let's do user service and do a new user service where we pass in the store. And then let's just register the routes like so. Now we can restart our server and go back to the HTTP client. So there we go, we created a user, we got a token. Let me copy to my dashboard, and I also to my clipboard, and I also have here the cookies set, has authorization. And if you go back to the database, let's refresh the users table, and you should see the user and the password, which is hashed as well, so we're not storing it as a text file. So now let's try again and create a task. So if you send, we still get permission denied, but if you go here to the headers and add a token, let me go ahead and try to send it. We got project ID is required, so we got authenticated, but we are still failing because the payload is wrong, but that is not the point, right? And as you guys can see, the API is basically working, it's getting shaped, and the only last things that we need to do is actually complete the project service. So I just need to basically add this logic, and I'm gonna leave that to you if you want to complete. If you don't, the code is going to be on the description, but this video is getting longer. So the last thing that we need to do is add a Docker image, and I'm going to show you guys how we can do this. So let's do a Docker file. So the first thing we do is we say that we want to get the Docker image, the official one from this version. So in my case, I'm running Golang 121.7. I get that version, and I'm going to call this stage as the build stage. Then I'm going to set the work there as /app, like so. Then let's copy the Go mods and the Go sum as well to the current directory. Then let's run Go mod download. After that, I'm going to copy everything that is a Go file into the current directory. And finally, let's just build the project. So it's going to be go build /API. But before that, we need to pass in some parameters, which are these ones. We just indent like so. And I think this is it for the build stage. Then for the, okay, so let's add the tests as I said. So let's do a from build stage. And let's call this as run test stage. And all we do here is run go test / verbose everywhere. Okay, so then finally let's create the release stage. So here I'm importing from Scratch. Scratch is an empty, it's basically doesn't have anything there. So we get it, we call it release stage. And finally we say again the work there is going to be /app on this stage as well. We copy from the build stage like so. Yeah, that's correct. So we get from that build stage, we get everything that it got, so those binaries, and we are exposing the ports 8080. And at the end, we just call the binary that we just copied, this /API. So to test this, let's open the console and do a docker builds Golang REST API, something like this. This is the name. And the Docker file is located here. Let's see if it works. So here we got an error, and I think it's because this is wrong. It's not like this, it's like this. There's also a space here, but that doesn't matter. Let's try again. There we go. So the Docker image has been built. So we just need to do docker run and the name of the image, and you're good to go. But yeah, guys, so this is it. We have built a complete RESTful API in Golang with multiple services, authentication, and we have even added dockerization, so we can ship this to the cloud very easily, and even a relational database to the server. So this is how I usually structure my projects if I want to go really fast. Hopefully you learned something valuable that you can use on your future projects, and if you liked it, give a thumbs up and subscribe if you want to see more of this. So see you on the next one.